Hi everyone, this is question 14 now on the paper. So this is paper 2 from 2023. Okay, so it says, show that the equation 2 tan theta 8 cos theta add 23 sine squared theta equals 8 sine 2 theta add 1 add tan squared theta can be written as that expression there. Okay, now I started off trying to do this as left hand side equals right hand side, but this is a little bit different. This is basically, we've just got to get everything from both sides of the equation over to one side. So let's start doing that then. So the first thing I'm going to do is take this 8 sine 2 theta over to the left hand side as well. So that's been taken over there to the left hand side. Now, next thing, what else can we do? Well, it's hard to know. Let's write this. We notice that we've got here sine 2 theta outside a bracket. So we could do with everything having a sine 2 theta. Now we've got a sine 2 theta already there, so we don't have to worry about that one. So somehow we could do with getting a sine 2 theta from this. So because we need a sine 2 theta from that, the first thing I'm going to do is write it as tan theta as sine over cos, because that at least introduces a sine for us. Okay. The next thing to notice is that 1 add tan squared is sec squared, and that sec squared is 1 over cos squared. Okay, so therefore you can basically think of that as 8 sine 2 theta over cos squared, which means that what we can do is multiply both sides of the equation now by cos squared. So I'm going to write down here, let's times both sides of the equation now by cos squared theta. So when we do that, we get 2 sine theta cos squared theta over cos, which is going to become 2 sine theta cos theta, which is perfect because that is the same as sine 2 theta, so that is great. And then over here, because this is the same as 8 sine 2 theta over cos squared, when we times everything by cos squared, that cos squared will just disappear, leaving us with minus 8 sine 2 theta. So that's great. So what we did is we used the fact that 1 add tan squared is sec squared is 1 over cos squared, and then times all through by cos squared. And that got us to this stage here now, where we can write the 2 sine theta cos theta as sine 2 theta, which means that we can take sine 2 theta out of the whole thing, leaving us with 8 cos theta add 23 minus 23 cos squared theta minus 8. So we're starting to look good now. The only thing to do is we want to write it in the form a cos squared, and it says plus. So I feel like we should multiply everything by minus 1. So we're going to times by minus 1, and that's going to have the effect of flipping all of these signs. So the minus 23, that says minus 23 cos squared, will become plus 23 cos squared, and the plus 8 cos theta will become minus 8 cos theta, and then we will have minus 15 as well, because it would be minus 23 add 8 if we times everything by minus 1. So that's good. So basically we've done that now, where A, B, and C are constants to be found. So we've got that our answer is sine 2 theta 23 cos squared theta minus 8 cos theta minus 15 equals 0. So yeah, that was pretty tricky. That was pretty tricky, but it is the second to last question in the paper. Now part B, it says hence solve that equation in the interval 0 to 540. Well, rather conveniently, when we put in this 23 cos squared theta minus 8 23 cos x squared minus 8 cos x minus 15 into our calculator, it turns out that it does actually factorize, which is kind of nice. So we just need to solve sine 2x equals 0, cos x equals 1, or cos x equals minus 15 over 23. So let's have a look at all of those. So the first one, sine 2x equals 0. Now notice that our range of values is from 540 to 360, the question says. So I've just drawn a bit of sine here, and in that range from 360 to 540 there are two solutions where sine equals 0. One is at 360 and one is at 540. So those are two solutions. Let's have a look at our cosine is equal to 1. Drawn a little bit of cos again, and in the interval from 360 to 540, that is this part here of cosine. So there's one solution there at 360, but we've already got it from here anyway. So x equals 360 is the solution to that one. And finally, let's have a look at our cos of minus 15 over 23. So I just do inverse cos of minus 15 over 23 and I get this value here, 130.7. That's out of the range. Now I've drawn a little bit of cos again. So there's my 360, there's my 540. So we're just interested in this portion of the graph here that I'm indicating now. We can see we're expecting just the one solution, and we notice it's one full wavelength on from where we are. So if we add 360 to the 30.7, we get 490.7, which is the correct and third solution. So those are the three solutions. So that actually turned out to be, apart from being a little bit challenging with the rearranging, the part B, which was worth more marks, was pretty straightforward. Okay, I hope you found that helpful, and I'll see you in the next video.